All right, so let's go through some examples for binomial expansion and Pascal's triangle. First of all, let's suppose I have 12 choose 8, and I want to compute that. Okay, so I know with my formula this is 12 factorial over 8 factorial, 12 minus 8 factorial, which is 12 factorial over 8 factorial, 4 factorial. I'm immediately queuing in on this largest factorial in my denominator with the numerator, and I'm just basically seeing, okay, what's left? Beyond 8, I have 9, 10, 11, and 12. So I have 12 times 11 times 10 times 9 over 4 factorial. Okay, I basically just did the 8, 7, 6, 5, 4, 3, 2, 1, and the 8, 7, 6, 5, 4, 3, 2, 1 from 8 factorial, and just canceled them all out. Okay, this is if I had to calculate it by hand, either literally by hand on a no calculator section, or maybe just with a very basic calculator in my work or something. So here I have 99 times, oh, actually, let's be smart here. 4 factorial is 4 times 3 times 2 times 1. So this is 12. That cancels that 12. 2, that can make this a 5. So I have 99 times 5. Okay, so this, well, actually, it's just 495. This I could calculate, right? 495. I'm able to do that without too much consternation. However, I could use Pascal's triangle. Now, going all the way to the 12th row probably isn't worth it just to find this one value. And I could also use my graphing calculator. So have a look here. In the graphing calculator, we have under math, which is just under alpha, we have a bunch of different functions. You may have used the cubed root before or something else. If you go over to probability, you have NPR and NCR. You even have a factorial button. So if I choose 3, N choose R, I could just type in the 12 and the 8. So I'll type in 12, push my over arrow, type in 8, and push enter. Boom, there it is, 495. Okay, so that you will find is very, very handy, especially later on when we'll have multiple NCR type calculations to do. All right, so that's one thing. Now, let's suppose we have an example like this. We have 3x minus 2y to the exponent of 6. All right, and we're asked to actually do this calculation. Now, I know in summation notation, that's kind of an ugly sigma. Let's be a little nicer here. In sigma notation, I know that this equals this. Right? So I could compute the whole thing this way, and I will. Okay, so this is saying that I have 6, choose 6, x to the 6, y to the 0, plus, and I carry on. But I've got to be careful here. This here, this 3x is what my x is. In fact, I probably shouldn't even put an x here for it. I should call this 3x. And y is in fact a negative 2y. Right? This is really the same as 3x plus negative 2y. And I have a 3x is the first part of my binomial, and a negative 2y is the second part. So here, I actually have a negative 2y. Down here where it says x to the 6, this is actually 3x to the 6. And where I have y to the 0, not that it will matter on this term, but it will on future terms, I actually have negative 2y to the 0. Okay, that makes a difference. So now I'll come through and I'm going to literally go through every single term. I have now 6 choose 6 choose 6. That should be 6 choose 0. 6 choose 6 and 6 choose 0 are the same thing. They both equal 1. So sometimes I could easily just swap one for the other accidentally, just like you might write down, I don't know, some fraction or some other fraction that you know is identical, like maybe 1 over 2 and 1 over negative 2. You might just treat them the same, even though they're not technically the same. I was just doing the same thing with my choosing. Okay, so then I have 6 choose 1. It's going to be 6. 3x to the 5, negative 2y to the 1. Then I have 6 choose 2, 3x to the 4, negative 2y to the 2, plus 6 choose 3, 3x to the 3, negative 2y to the 3, plus 6 choose 4, 3x to the 2. So it's going right, 6, 5, 4, 3, 2. Yep, that's fine. 0, 1, 2, 3, 4. Yep, that's fine as well. Okay, great. Plus 6 choose 5, 3x to the 1, negative 2y to the 5. And my last term is 6 choose 6, which is 1, 3x to the 0, negative 2 to the 6. Okay, so I'm following the same pattern, and I'm just using choose notation for my coefficients. Now, I need to simplify this, and to make it easier, I'm going to use Pascal's triangle here. Okay, now, after you've done Pascal's triangle a few times, you actually start to get used to it. So I can actually jump ahead and not write out every single row, especially when I'm in a unit where I've been practicing using Pascal's triangle, but I can also generate it pretty quickly. So n equals 0, 1, 2, 3, 4, 5. Oh, sorry, we're getting down to 6. 6, 15, 20, 15, 6, 1. There we are, row 6. So we have 1, 6, 15. This is 1, this is 6, this is 15. Then we have 20, then we have 15, then we have 6, and then we have 1. Okay? So that's just applying Pascal's triangle for my coefficients. No need to actually compute them. Anything to the 0 is 1. So that's gone, and that's gone. And now I can start to clean this up a little bit. Now I'll get rid of this Pascal's triangle now that I no longer need it. I can just erase that. And let's see here. So my first term now, I'll change colors just to make it a little clearer, is 3 to the 6 x to the 6 plus 6 times 3 to the 5 x to the 5 times negative 2 to the 1 y to the 1 plus 15 times 3 to the 4 x to the 4 times negative 2 squared y squared plus 20 times 3 cubed x cubed times negative 2 cubed y cubed plus 15 times 3 squared x squared times negative 2 to the 4th y to the 4th. I'm just looking up at each term, applying my exponents to the bases. Then I have plus 6 times 3 to the 1 x to the 1, negative 2 to the 5, y to the 5. And then my last term here is 1 times negative 2 to the 6, y to the 6. Okay. And so then now 3 to the 6. Here I might have to actually calculate it out. I have 729. I'll change colors again. 729 x to the 6 plus 3 to the 5. That would be 243 times 6 times 2 negative. So this is actually minus 2,916 x to the 5y plus, this is 81 times 15 times 4 times positive 4. So that's going to be 4,860 x to the 4y squared plus, here we have 27 times 20 times negative 8. So this will actually be a minus. Let's calculate this here. 20 times 27 times 8. So 4,320 x cubed y cubed plus 15 times 9 times 16 is what that is. 15 times 9 times 16, 2,160. And that is x squared y to the 4th. And almost there. 6 times 3, that's 18. Negative 2 to the 5, that's negative 32. So it's actually a minus. We have our 32 times 18. That's going to be 576. X, y to the 5. Plus, at the end, negative 2 to the positive 6. That's going to be 64 times 164 y to the 6. Okay, so a bit of a messy answer, but I'll tell you, this is actually a pretty involved question, going to the exponent of 6 with the 3 and the negative 2 as coefficients. All right. Next, suppose the question says, find the 9th term in 2x minus y to the 12th. Okay, this is an extremely important question to be able to do. This is a very common question. Now, with n being 12, I don't really want to do Pascal's triangle. That's a little bit too much work. And I'm only getting a single term. Okay, I do not need to do the entire expansion. I just want a single term. So I am for sure coming and using this formula here for the kth term of a binomial expansion. Okay, I'm just going to copy and paste it down below. The kth term is given to us by n choose k minus 1 x to the n minus k minus 1 y to the k minus 1. Okay. In other words, you just need to take the term number and subtract off 1, and that's what you're going to put here, here, and here. Again, this is just an adjustment, as we discussed in the last video, so that we can call the very first term here the first term and not the 0th term. Okay, that's all this is doing. So I'm going to go and I'm going to get 12 choose 8 x to the 12 minus 8 y to the 8. Okay, very, very simple once I've written it this way. So my exponents, I've already done them. I just need 12 choose 8. Now I could do that without a calculator pretty easily, but let me do it with a calculator just to review that. So I'm going to bring up my calculator here. I'm coming to math. I'm going over to probability, and I'm coming to NCR. And I'm going to put 12C8. Well, that's what we already did. That's funny. 12, and over here I'll put an 8. Enter. Obviously, I get 495 again. So then I just have 495 x to the 4, y to the 8. Okay. Again, if I needed to do it without a calculator, it would not be so bad. This term here is n minus r. I'm going 12 times 11 times 10 times 9. The rest I don't write because the 8 factorial gets rid of them. And then I have divided by 4 factorial. 4 times 3 times 2. And 4 times 3, that is 12. 2, that makes a 5. 99 times 5, 495. Okay? Very, very, very important question. And very important that you remember to subtract off the 1 to make sure you're getting the correct term. Okay? If you're ever not quite sure, calculate the first term first. And you'll notice pretty quickly that you need to have a minus 1 to make it work out. Okay, last question here. Let's suppose we have a question that says something like this. We have a binomial expansion and it says in x plus 1 over x to the 9, find the term containing x cubed. Okay, now this is a little bit trickier because it doesn't tell us exactly which term we're looking at. Right? If we were at the first term, we would have x to the 9, 1 over x to the 0, which is x to the 9. That's not x cubed. The next term would be x to the 8, 1 over x to the 1, which is x to the 6. To the 7. That's not x cubed. Okay? But actually, for this one, we could just keep going and pretty quickly figure out which term it is. I could even just do it this way. X to the 7, 1 over x squared, that's x to the 5th. So it's actually going to be the fourth term, right? X to the 6, 1 over x cubed, that's going to be x cubed. So that's actually the term we're looking for, okay? The fourth term. And from there, I could actually just use this formula right here, and is pretty easy, pretty straightforward actually overall. Yeah, actually, let me just think here. Is there another way I want to talk about it, or is that good enough? No, that's actually exactly how I was going to do it. Okay, so I've gone through the terms. I've discovered that it's the fourth term that has this. And now I just need my coefficients, because this one, of course, is going to be, what's our n here? Was it 9? I'm a little bit frozen. Here we are, 9, choose 0. And then we have 9, choose 1. 9, choose 2. 9, choose 3. Actually, this is an easier problem than I even intended, because now this can just be calculated. Okay, well, I'll just do it then. And then maybe I'll show you another little way. So now 9 choose 3 is 9 factorial over 3 factorial, 9 minus 3 factorial, which is 6 factorial. So I've got 9 times 8 times 7 times 6, 5, 4, 3, 2, 1 divided by 6, 5, 4, 3, 2, 1 over 3 times 2. What can I do here? Well, this becomes a 4. This becomes a 3. I'm left with 12 times 7. So that's going to be 84. So my coefficient is 84. 84 x to the 6, 1 over x to the 3, which is 84x to the 3. Does that answer the question? Yeah, that's the question. Now, another way to do it, of course, once I found it's the fourth term, I can use the formula. The formula is from the binomial expansion. The binomial expansion says this. And because I have to adjust for my terms, we say the kth term is given by n, choose k minus 1, x to the n minus k minus 1, y to the k minus 1. So when I found out up here that it's the fourth term, just by evaluating what would happen with my x and 1 over x bits and waiting to see when this would work out to x cubed, as I was asked for, I could now just use this formula here. So I have that n is 9. So I can just say 9, choose fourth term, so 4 minus 1 is 3, x to the 9 minus 3, y to the 3. And in this case, my x is actually an x, and my y is 1 over x. So my x is actually an x, my y is 1 over x. And so I'm going to calculate 9, choose 3, just for fun. I'll pull up the graphing calculator this time. 9, choose 3, I go math. I go over to probability. I go n, choose r. 9, choose 3, enter. I get 84. So I have 84 x to the 6, 1 over x cubed, which is, of course, 84x cubed. Same answer as before. Okay, I hope you find that helpful. And now you're well prepared to tackle the questions in the binomial section. That would be, what are the exercises again? Where did they go? Exercises 1N and 1O.